Okay, I'm going to try to go through this last section in chapter 1 that talks about misuses of statistics. And on this first slide here, I do have just some quotes about statistics and highlighting misuses that have happened. This Mark Twain quote, "Figures don't lie, liars figure." There are times, and we'll talk about this a little bit later with misleading graphs, but sometimes people use graphs and charts to kind of say a picture that's really not the true statement there. So, we don't want to do that. And then some people use statistics as a drunken man using the lamppost for support rather than elimination. So, the idea that people can use statistics to kind of say whatever you want to say, pass whatever agenda off that you want, that's kind of highlighting that misuse there. And then 58.6% of statistics are made up on the spot. We don't want to make up statistics, so, I actually made up this quote myself, so that's the author of that one. But all these things right here, we're going to go through misuses of statistics that are present, and we don't want to do that ourselves. That's the main goal of this section, is looking at statistics and misuses that are out there. And hopefully these are things you'll think about when you're doing your first project as well. I'm not watching you collect your data. I'm not asking you to tell me how you collect your data for your first project. So, you can really go about doing it in a variety of ways to get your 30 quantitative values. But it might be something to think about in the back of your mind, what misuse of statistics are present when I'm doing this. If you want to do a legit study, you may want to try to do the least amount of misuses as you can, so you can get good data. But anyway, let's go through some of these. This first one here, bad samples. There are a lot of different types of bad samples out there that yield bias in your data. And I have a couple more bad samples that are going to pop up, like small sample. Non-random sample is a type of bad sample as well, so if you want to be more specific. But one very good definition I always like to ask students on the first test is voluntary response sample. This is a really good definition to know, because you see this one a lot when you're reading, you're reading studies or something, when they talk about how they collected their data. And it's one where respondents themselves decided whether to be included or not. So think about if you're on the internet. And in voluntary response sample, there's a lot of these, like polls that you send out that people have the option to click on or not. On the internet, you might see this poll about air pollution on the side or something. And, what causes air pollution the most? It might have some options like traffic, factories, or, industry, whatever. They might have some different options for you. Well, normally the people that are going to respond to this, who are the people that are going to respond to this poll? Well, it's just the people that are interested in air pollution or interested in the environment. So you have a really small population. It's usually not your intended target population. You might have been trying to get all web users, but really, you're getting all web users that are interested in environmental issues, because people that are not interested in environmental issues are not going to click that. So that's one thing to watch out for. Anything that's like a poll that people have the option to do or not, mail-in polls, phone call-in polls, these samples, you can still use them to make conclusions, but it's usually about a specific group. You can only conclude about a specific group, and not usually your intended entire population there. So just be careful of that one. I mentioned small samples. You don't want to use a sample that's way too small to study. So, like if you're doing household incomes for like the state of Tennessee, you don't want to gather just 10 households and then use those, for your data, because that's way too small of a sample to try to learn about your entire population. And then this example here that I have on here comes from your book, but I talked about a school reporting 67% of their students were suspended at least 3 times from high school. But the publication actually only used a sample size of 3 students. So I guess 2 of them were suspended 3 times and the other one wasn't. So really, really small sample size, to use to get this number right here, and you don't want to do something small like that. Correlation and causality. And you might want to write something like this beside this, but the statement I always tell students to write is correlation does not imply causality. And what does that exactly mean? Well, in statistics, we do talk about how data correlates to other data. Is there a correlation between, when this rises, does this rise? Or, when this rises, does this fall? What's going on here? And just because we do see those relationships, just because we do see those correlations between data, does not mean that one variable necessarily causes the other. So take, for instance, smoking and the development of lung cancer. You can often find a large correlation between those two things. But just because, as you smoke more, it's looking like, lung cancer is there. Just because that does happen, we see that connection there, doesn't mean that cigarettes themselves do cause lung cancer. We don't say that in statistics because we don't know. There are things that could have caused the lung cancer in our people that we didn't even think about looking at. Like there could have been some kind of environmental thing. There could have been some other factor involved there that actually did cause the lung cancer itself. We don't know. It could not have been smoking necessarily. So just because we do see, those kinds of correlations in statistics, we don't say that this one caused this one. We don't do that. We don't know. Like I said, there could have been things we didn't even think about studying or looking at that actually did cause, the other thing to happen. So we just say, hey, there is a correlation. There is a relationship here that's going on. There's a connection possibly here, but we don't know what caused it. Percentages. I don't know if this one's really that important nowadays. I don't really see this one misused a whole lot, but there are times where it is misused, especially when you're speaking colloquially. Like I gave 110% effort. You don't want to say 110% effort because you can't have over 100% of something. You can't give more than 100%. So misuse of percentages is usually percentages where you're giving a quantity that's over 100%. So you just want to be careful of that. I don't say that one a whole lot though. And I do have some examples of percentages here. I may try to work those out in maybe another video, or maybe in class I may try to work those out and just have those examples there for you in case. I think there's maybe one example on the homework that goes with this, but not a whole lot of examples on the homework. So I don't think you'll have a lot of trouble with that one. Loaded questions. So if you look at these two examples right here below, I guess, the one where we have 97% said yes, and then 57% said yes. Okay, these little statements out beside, they're the exact same question asked, but there's a little difference, a small difference. So the first one says, should the president have line item veto to eliminate waste? That one right there. And then the second way, they kind of reworded it just a little bit. Should the president have the line item veto or not? Now, the only thing they really changed is this last part here, eliminate waste. They changed that to like line item veto or not. Why did more people say yes? It's the same question, just worded a little different. But why did so many more people say yes when it was worded this way than when it was worded this way? Well, it's because when you're reading this one, you get the connotation of eliminate waste. Like, oh yeah, I want to eliminate waste. Eliminating waste is a good thing. Yes, let's do that. So you want to say yes on that. So sometimes questions are loaded. Now, it doesn't necessarily have to be intentional, but a lot of times it is intentionally done. It's better to have this kind of neutral phrasing down here, honestly, so that people can kind of decide themselves. You're going to get a better response here. But sometimes people do load the questions intentionally to get a certain particular response that they're desiring. So, just be careful that you don't want to be, causing that yourself. You always want to think about your questions, your survey questions, so that you get the best representation, the best answers from your people that you're surveying. Missing data. This misuse here, this is basically saying that there are times where you may be missing certain parts of the population that you're actually trying to study. And I mentioned this maybe a little bit in class, but there are times, like the Census Bureau, it has trouble with getting low-income families, households, to report their income. So the census does suffer from this missing data. Now, you can still use your data that you collected in your report and write it up, but you do need to make some kind of special blurb that says, I'm only able to accurately report on the households that are in the mid-range or the higher range, because I'm missing a lot of data from the lower end household, that spectrum. So you just want to be careful when you're missing data, but you can still use your data. You don't want to talk about areas though that you don't have data for. Make some kind of statement saying this is what I have, but I am missing a lot of data, or I'll have good representation in this area. Order of questions. Some people get this kind of confused with loaded questions. So looking at these two phrasings of this survey question down here, would you say that traffic contributes more or less to air pollution than industry? Okay, so there's that one right there. And then would you say that industry contributes more or less to air pollution than traffic? So it's the exact same question, honestly. They just kind of changed the order of, let's see, they just changed the order that traffic and pollution are introduced in each of these question statements. Now, do you think that will have an effect on the answers that people give in the surveys? Yes, it does actually have a effect. When traffic was presented first, more people were likely to blame traffic than industry. And then when industry was presented first, more people gravitated toward the industry. So it's like the first one they seen, they were likely to be drawn to. Now, the order of questions, kind of how it differs from loaded questions, is order of questions a lot of times happens unintentionally. So people don't really know they're doing it, but it ends up being that way. And you might not know that when you're making your survey. You might not realize that you affected the outcome by the way you kind of introduce things in your wording. So you can always make a statement at the end that this could have affected your results. But the best thing is to kind of, maybe change the wording a little bit. Change it to a different kind of question, like, what do you think contributes the most to air pollution? Okay, you could ask it in kind of a neutral way, or something, and maybe have options, or maybe let them do like a fill in the blank kind of deal. Who knows? So lots of different things you can do there to change it up so you get good results. Self-interest survey. So self-interest studies, those come from when somebody usually has an interest at stake, that you need good results because you're trying to sell a product or you're trying to appear a certain way, so that you don't lose money, you don't lose customers, you gain customers. And a lot of times in the past, where you've seen the most of this kind of stuff happening in this self-interest study was with pharmaceutical companies would pay physicians or doctors to use their drug, their medicine that they had created. And of course, the doctor and the clinic are going to want to report back good stuff to them. So the results are going to be really biased because, obviously, they're getting paid by the pharmaceutical company to do this and to run the study. So they don't want to give them bad results back. So yeah, I mean, it's become less of a problem nowadays, but it could still be out there. It was in recent years, obviously a big issue. And of course, you could have all kinds of things going on, like political spectrum. You could have big industries paying, political candidates money. Of course, the political candidate then in turn will hopefully, give them some good publicity or maybe help them out somehow when they get elected or whatnot. So you have a lot of things going on here with self-interest. Just be careful. You always want to look at who's running, the study. How are they getting paid? You kind of want to dig in depth and just see, like, what are all the kind of things in the background going on with the study and the information and the data collection, so that you can see the full picture. Reported results. So reported results. This one right here, and I'm hoping when you do your project, you can maybe get around doing reported results, but a lot of people have to use reported results, obviously, when they're doing their data. But it's best when you're collecting data from people, like weights, heights. It's better to take those measurements yourself or get them taken yourself somehow, because people are more likely when you ask them, like, okay, how much do you weigh, or how old are you? They're often going to give you kind of some desired idea weight that they want to achieve, or maybe a height that they estimated, rounded somehow. So you always want to take these things yourself, so you have good, accurate data to use for your studies, for your to run with. So just be careful with reported results. Precise numbers here. Beware reports that use very precise numbers. So this one says there's 103,215,027 households in the United States. So that is like a very specific number of households. It's really better to say maybe like there's about 103 million households in the United States, or something like that. Use kind of a rounded kind of number, or an estimate kind of number, because numbers like this could very well be made up. It's so precise. You know, and new homes and things are being established each day. I mean, did they count every house? Did they actually get them all? You know, I'm really suspicious of this. So, you know, that's kind of the red flag right there. Just be careful with really precise numbers, for sure. Misleading graphs, and then I think this is my last misuse that I want to look at here. But I did talk about earlier that graphs can be kind of drawn or created to say, you know, a picture that's not really there, to say something that's not really true. And I want to give you some examples of that in the next graphs on the next few pages. So these two graphs right here actually have the same exact information on them. This is talking about personal household income for California and Nevada, and you know, 32,000, a little bit over 32,000 for, or over 32,000 for California, and then 30,000. Well, yeah, just a little over 30,000 for Nevada. So it says the exact same thing on both slides, though. However, you know, do you think one of these two slides possibly, you know, could be misinterpreted or misleading? And a lot of people gravitate toward the B one. The B one is misleading. And why is it misleading? Or why could it be construed to be misleading, maybe? Well, if you look at this one, like they start the labeling at $30,000 down here. And now it looks like Nevada makes so much less than California. They're only about 2,000, a little, 2,000, a little over 2,000 difference here. But you know, this gap right here on this B graph makes it look like so much more of a jump between California. California people are making a whole lot more than Nevada, but it's not necessarily true. So this is definitely misleading. And, you know, just think about when you're watching newscast at night. You know, they only have these graphs up for a few seconds at most. You don't have a lot of time to take in the whole picture itself. You know, it's just flashed up there on the screen real quick, and then it goes on to the next segment or whatever. Well, this one right here will be kind of a little bit misleading. People are looking at this thinking, oh, I'd rather live in California. You want to have something that's a little bit better representation right here, such as this one. So yeah, make your graph start at 0 if you can. You can't always do this, but I do think it's a really good rule of thumb. And you can always make your scale, you know, start at 0. Your scale might be big jumps, you know, to get it in. Like if you have really high numbers, you can have your scale kind of do whatever you want it to do. The scale on that last one up there, it went like, 10,000 each. So you can make your scale to whatever. So yeah, let's look at some more misleading graphs real quick. This one right here. This graph itself is kind of weird. I mean, they're talking about money amounts that people make after they get their degrees or whatever. And they have, of course, a money, you know, dollar bill in the background, this imagery right here. To me, I mean, I can kind of tell what they're saying. It's easy for me to kind of read it. I see it pretty well. But there are times where people might not be able to tell, like, where the divisions are. These bars, you know, you can tell they kind of jump. You can tell the jumps pretty easily, but if the jumps were a little bit closer, it might be harder to tell, you know, which one's larger and which one's smaller, you know. They do have the numbers over here that'll help, but there's a lot of busy imagery in here going on that just kind of clutters up your graph, and you don't really need that so much. It's very hard to tell where your bars kind of like end at and begin at for each of the classes. We talk about graphs in the next chapter, but these are like your classes. You can't really tell where each class begins and ends right here. So kind of a weird graphic there. And then this one right here, these have these 3D boxes representing these same kind of thing, income that you make, average income you make with these degrees. You know, you have 18,000 here on the no high school diploma, but then like about 4 times that, if you have the advanced degree, you make 74,000. Well, these little cubes, if you're looking at the volume comparison, you know, 18,000 4 times smaller than the 74,000. But this little cube right here, if you're looking at cube volume, like you could do 1, 2, 3, 4, 1, 2, 3, 4 stack, and then 1, 2, 3, 4 depth right here. That's 64 times bigger volume cube than this little small cube. So these cubes are like, you know, 1 over 64 versus the money amounts are 1 over 4. So very different kind of ratios there, disproportionate ratios going on with the images versus the money amounts. So you can kind of see what they're doing, but yeah, it's some misrepresentation there if you're looking at the volumes. So yeah, the first graph, I just wanted to say right here, this kind of sums it all up right here. First graph, very busy. lots of stuff very difficult to read. For some people, very difficult to read with all the imagery. You don't want to have it all cluttered up, so take out the imagery. The second one has that 3D effect. It's really good to try to not use a 3D effect when you're representing things because, yeah, I mean, this right here tells you the whole thing. 4 times bigger the money amounts, but 64 times the volume amounts. So be careful with that. This right here is a simple graph, very easy to read and understand. This is all you need in statistics. So you have your simple bars. There are options in Excel when you're working with graphs. You can put the little money amounts on top of it, bars to show you how far they rise up. But yeah, simple bars, easy colors, no busy imagery. Awesome. What is labeled at 0? Axis starts at 0. So this is a great graph right here. So yeah, and this is just some some misuse of statistics. There are a lot more misuses that we don't cover in the class, but go through these, look through these. You can fill in your notes on whatnot on this, and I have some questions maybe on the test about labeling misuses of statistics. Some of the things that you remember from this. Usually I have like a scenario too where I have all these misuses, and then you have to pick out the misuses of statistics from like the paragraph. So I really like that kind of activity where you're reading, analyzing, and thinking about things. So look over these and review, and then there's some homework problems. 14 through 23 on the homework will be messages of statistics. Okay, bye.